Warning! Ethyl acetate is highly volatile and extremely flammable. Any open flames should be avoided. The experiment should be performed in a fume hood or in a well-ventilated area. Gloves, goggles, and lab coat are absolutely mandatory. Vanillin is the molecule responsible for the characteristic flavor and odor of vanilla. Vanillin is naturally produced by vanilla plant, however it is present in a quite small amount, thus most of the vanillin which is used worldwide is synthetically produced. The extraction of vanillin from artificial vanilla extract can be a nice experience. It is preferable to use artificial vanilla extract rather than natural one, as the natural one will contain much more stuff in addition to vanillin. Materials and reagents needed: 200 ml of artificial vanilla extract, 100 ml of ethyl acetate, saturated solution of sodium chloride, separatory funnel. First, the vanilla extract is poured in the separatory funnel, then, 25 ml of ethyl acetate are added to the separatory funnel. The separatory funnel is then mixed thoroughly but with care, trying to avoid the formation of an emulsion in between the phases. If this happens, we will not have a proper separation of the organic and the aqueous phases. Once the two layers are settled down, the stopcock is opened and the aqueous phase is drained out. The organic phase is poured in a clean beaker. This process is repeated 3 more times using 25 ml of ethyl acetate in each. Actually, the yield of a liquid-liquid extraction increases with the number of extractions. Thus is better to perform 4 extractions using 25 ml each rather than one single extraction using 100 ml. Due to the additives on the vanilla extract, is quite difficult to clearly see the interphase in between both phases. Once the last extraction is finished, the organic layers are placed together in the separatory funnel. As you can see, the organic layer is quite dirty and it has a lot of water in it. In order to clear things up, we have to wash the solution with brine. Then 30 ml of brine are added to the separatory funnel. However, the separation in between the organic and the aqueous phases is not very well resolved, so I decided to centrifuge the solution. Now the organic phase is much clearer. Finally, another 5 ml of brine is added to wash the organic phase. The organic phase is then collected in a clean beaker. The organic phase is then dried using anhydrous magnesium sulfate. The magnesium sulfate will get hydrated, removing the moisture from the organic phase. When the magnesium sulfate is a free-flowing powder, the organic phases is already dried. The solution is then filtered and placed in an appropriate flask. "10 ml of ethyl acetate are used to wash the surface of the magnesium sulfate in order to obtain maximum recovery of the vanillin. In the meantime, a minimum amount of the solution is analyzed by TLC and is compared with a standard sample of vanillin. The TLC plate is then viewed under the 254 nanometers light. We can clearly see 2 spots on the TLC plate with the same RF value. We can confirm that our solution contains vanillin. The majority of the solvent is removed using simple distillation. Some activated charcoal is added to the receiving flask in order to eliminate any compound from the recycled solvent. After filtration, the solvent could be recovered and reused. Once it is completely dried, the crude vanillin looked like this. it contains some impurities that we can remove by recrystallization. In order to recrystallize it, we add about 20 ml of distilled water. The beaker is gently heated until everything is completely dissolved, however we have to keep the temperature below 80 Celsius degrees. If not, the vanillin will melt, which difficults the crystallization after cooling. Here you can see the crystals already formed in the solution. While the impurities remain in solution, the crystals were dried under vacuum. Here you can see our relatively pure vanillin. It is still contaminated with some impurities. It can be further purified by recrystallization, but for me it is fine like this. The final yield was 1.27 grams of relatively pure vanillin. Thanks for watching.